Well, you've all heard about net zero, I suppose. And what is it all about? In 2015, the world is supposed to have got out of carbon fossil fuels. Emissions by economic activities is not supposed to exceed the absorptive capacity of the planet, which is thought to be 2 gigatons per year, whereas the so-called anthropogenic emissions are about 40 gigatons per year. So you can immediately see that this is an enormous undertaking. Now, this net zero 2050 is, in my view, totally utopian. And it's not even desirable, even if we wanted this to happen. The necessary economic restructuring is totally unrealistic. And I will show you some examples from a publication from the International Energy Agency, which underpins that argument. And then in addition, most countries in the world have other priorities than to reduce emissions of carbon dioxide, and for a very good reason. Now here are diagrams taken from one of the publications of the International Energy Agency, which for a number of years has analyzed the necessary reduction in emissions to realize different goals, net zero being one of them. And you can see further to the left where we would be according to the what is called stated energy policies, or maybe we could call it business as usual. In the middle, you can see something called the announced pledges scenario, which is what some countries have said they will do, probably without meaning to live up to it, and certainly without the ability to live up to it. So furthest to the right, you see the net zero emissions scenario, and you can see that even if countries kept what they promised, we are far away from realizing this net zero emission undertaking. Now, those of us who have a few years on our back, we have heard this, we've seen this film before. And I'm going back now to 2012, to another publication by the International Energy Agency. Back then, all the talk was about 450 parts per million. And 450 parts per million was something that we were supposed to be able to afford of emissions without temperatures rising to more than 2 degrees by the end of the century. And these parts per million refers to the concentration of carbon dioxide. And then the International Energy Agency did us the favor of calculating different emissions paths. One path which shows what we would have to do in order to keep this, attain this goal of 450 parts per million. And that's a green path that you can see. And then you can see a blue path, which is called the new policy scenario. That was the what several governments in the world have promised to do. And then finally, there's a red path, which shows what they call the current policy scenario. And now I put a black line in 2024, and you can see where we are, or where we were rather. We were very close to the red path in terms of emissions, and certainly very, very far away from the necessary path to realize the goal of 450 parts per million. So my hunch is that we will probably be about as far away from realizing our net zero 2050 goal in, let's say, 15 years as we were in 2024 from realizing the 450 parts per million goal. Now here are some interesting quotes from a special report that the International Energy Agency published about the net zero 2050 goal. And here they say our pathway calls for scaling up solar and wind rapidly this decade. For solar photovoltaic, this is equivalent to installing the world's current largest solar park roughly every day. Now, do you think this is likely to happen? I doubt it. And it sometimes occurs to me, is there some serious, sober person on the writing team which smuggles in here and there some phrases that shows how ridiculous this entire process is? And here's another one. Total consumption of fossil fuels rebounds marginally following its 5% drop in 2020. This was the COVID-19 year. But it never returns to 2019 levels in the net zero emissions scenario. And this shows you what happened. It took 1 year for the consumption of fossil fuels to recover its 2019 level. And from there on, it's been increasing year by year. Now, you may remember when this report was presented, I think it was in Oslo, some people took this as an argument that now we don't have to find any more oil fields or gas fields. We have enough as it is. Well, see how that went. Fortunately, on the Norwegian shelf, we have found several large finds since 2020, which I think is all for the better, since there will certainly be a market for the stuff for decades to come. Now, here is yet another quote from Net Zero 2050. To achieve the Net Zero 2050, we need to increase production of critical minerals several times the level of 2020. Graphite, 25 times, lithium, 42, cobalt, 21, nickel, 19, rare earths, 7, and not to mention aluminum and copper, maybe not as large figures, but large figures anyway. So it has occurred to me that rather than talk about the green transition, we should talk about the dirty transition. I suppose you're all familiar with mining, and especially mining in Africa, where they mine a lot of this lithium with child labor, with not even the most basic security arrangements. One more good quote from this publication. The world economy in 2030 is some 40% larger than today, but uses 7% less energy. Are we supposed to believe this with more people in the world? Just for your information, since 2000, the world demand for energy has increased by 1.8% on average every year. And I think it is very likely that that is going to continue at least up until 2030. Now here is a diagram showing you the use of energy, sources of energy since 1990. And as you can see, almost all of this is fossil fuels. Look at king coal, still growing, despite its everything that is said about it. Then you can have a look at solar and wind that I have put in orange color. It's so small that you hardly see it. And as a matter of fact, solar and wind are responsible for 3% of all primary energy that is produced. 87% comes from fossil fuels. And for sure, that's not going to be an easy process to wind down, even in the time that we have until 2050. And you can see what this also means for carbon dioxide emissions from energy. They have continued to grow. And they continue to grow despite all the efforts of developed countries to reduce them. because of increased emissions in so-called developing countries, in poor countries, medium-rich countries, which have totally different priorities from what the rich countries in the world have. Here you can see a diagram of emissions of carbon dioxide from energy. There are some other emissions which I have ignored here, but this is from energy only, but that's anyway about 90% of all so-called anthropogenic emissions. And I picked the year 1997 because that was the year the Kyoto Protocol came into effect, for those of you who remember that. And as you will also remember, the developing countries, the poor and medium-rich countries of the world, they were exempt from the reductions in carbon dioxide that should be undertaken. And look at what happened. The rich countries in the world, they have managed to reduce their emissions, yes, but the poor and medium-rich countries, they have more than made up for it. And total emissions in this period from 1997 to 2024 have increased by about 50%. And that increase is coming from the medium-rich and poor countries in the world. Now here is a table showing the 10 countries of the world where emissions have increased most from, between 2014 and 2024. And what characterizes these countries mainly, they are populous and poor. Populous and poor. In the column furthest to the right, you see the GDP per capita in purchasing power parity, in percentage of the American GDP, again in purchasing power parity. And you can see that most of these countries are way, way, way below the level of richness that the United States has. And what do these countries aspire to? They aspire to develop their economies, to increase their well-being, maybe reach the level where we are in the United States and other rich countries. And they realize that the only way to do that is to increase their use of energy. Actually, those two things go hand in hand. Increased production, increased use of energy. They are just like Siamese twins. And then there is the question, where does the energy come from? And the cheapest and most convenient energy is fossil energy still. It's not wind and solar power that delivers its products every now and then. So that's the reason why these poor and medium-rich countries have increased their emissions year after year after year, despite everything that the rich countries in the world have been trying to do. This is a sobering thought. 6 countries in South and East Asia account for 45% of the world population. This is where the question of carbon dioxide will be decided in the years to come. It's not going to be decided in small countries like Norway or even medium-sized countries like the European Union. Now, here's a graph of world emissions and emissions from Norway. And you can see that the emissions from Norway are missing. And they are missing not because I forgot them, I put them in there, but they are so insignificant that you don't see them in this diagram. And yet here we are talking about the need for having a climate policy, reducing carbon dioxide, and on and on and on. If there has ever been anything in the world that is inconsequential, it is Norwegian climate policy. But it's not going to have any discernible effect whatsoever on the world's climate. So we had better forget about it, sooner rather than later. I think these animals show pretty well the proportions that we're dealing with here. Now, let me then turn to Europe's green transition. What they've done is to replace cheap and controllable energy with costly and non-dependable energy from solar and wind. And then we are being told repeatedly how cheap this renewable energy is. And the figures that people are then quoting is usually what is called the levelized cost of energy. And why is that levelized cost of energy so grossly misleading? It's because it doesn't take into account the backup capacity that you need to keep the lights on when the wind doesn't blow and the sun doesn't shine. What you need to have is a double system. Wind and solar and gas turbines or coal or whatever it is. And it goes without saying that a double system, rather than just a simple one, is a lot more expensive than it would be to have to use a traditional system of supplying energy. Now here are some curves showing the production of wind power in Germany at 15 minutes interval in 4 months of 2023. Look at September. Long periods almost without any production at all. And then a lot of ups and downs, and somehow you have to fill in this gap. Nobody is going to suffer happily being cold in the darkness. You have to produce some substitute energy to make up for these gaps. And that's what makes solar and wind power more expensive than you would think. Besides all the other problems that it causes, which I don't think we have time to go into, but that's another story. Here is solar production on the first day in the month, again in Germany, the first 6 months of the year in 2023. And of course, there is no solar power at night. There is solar production in the middle of the day, yes. Look at the huge difference between July and, well, look at January and February. You can see that the production of solar electricity is actually higher on the 1st of January than 1st of February. And isn't that funny? Because I would have thought that there is more sun ordinarily on the 1st of February than there is on the 1st of January. So what's going on here? Well, I have to admit I haven't researched that question in any detail, but I suspect it's cloudiness. Because solar power, how much you get out of your solar panels, depends critically on the cloud cover that you have. So my hypothesis would be that it was overcast on the 1st of February and not on the 1st of January. So again, that shows you the unreliability of this type of a power source. Here's a diagram from Scotland. This is for offshore wind energy in Scotland, which has increased quite mightily between 2010 and 2021. Look at these deep red areas in these curves. This is curtailment. Well, what's curtailment? It's just that they shut off the wind power. The wind park should have been producing, there was enough wind, but they just had to cut it off. Why did they have to cut it off? Well, one, there probably was no demand for it at that particular time. And two, it may have been because there is not sufficient grid to transport the production of wind power to the parts of Britain that need it. So that's another illustration about the non-dependent wind source of energy. And well, this publication informs us that the maximum production of wind is 3 times the average, and that the maximum production of sun is 10 times the average. So it tells you something about the enormous variability of these sources. Variability that they have no control over, and which we have to deal with somehow. Now, let me tell you a story about Germany. You all know what has happened in Germany. Germany has replaced its nuclear power stations with solar and wind, mainly wind. And here you see the blue curve showing that the generation capacity, generated capacity for electricity has about doubled from, well, early this century up until 2022. The production of electricity has stagnated. So they have doubled the capacity, don't produce anything more. And well, this has cost them an arm and a leg. One number that I've seen is it has cost them 500 billion euros. And I shall admit that when I see such large numbers, I get a headache. What the hell do these numbers mean? We have to put them in relation to something. And fortunately, this gentleman who wrote this book that I'm taking these numbers from, he did that. This cost is equal to 40 Olkiluoto nuclear power plants. The Olkiluoto power plant is in Finland. It's a notorious place in many ways because it took, I think, more than 14 years to build, and it exceeded its cost enormously. And yet, with all that said, the Germans would have gotten 40 such plants with the money that is spent on solar and wind power. Now here is some more stories from Germany. You can see how solar and wind have replaced the nuclear power. They have phased out the nuclear power totally. And what have they got in return? If you look at the emissions, you can see from the panel to the right that the emissions have been reduced maybe by something like a quarter. And the coal consumption, yes, it has fallen by half, but it's still quite big. And this is one of the sources that the Germans taken to use when the solar and wind don't deliver. There are actually some fascinating stories about Germany tearing down some wind farms just to be able to mine some more coal. So coal is not out of the picture in that part of the world by any means. But you can ask the question, what have they achieved for all this cost of new power plants? Now, not surprisingly, the cost of energy both for households and industry, this is for households, the cost of energy depends quite strongly on the share of solar and wind power in the generation portfolio. The countries with highest electricity prices are the ones that have the largest share of solar and wind power. You can see some of them here, Denmark, Germany. And those that have the smallest share, like South Korea, they also have the lowest electricity prices. And you can see that the United States is pretty low in terms of electricity prices, nor do they have a very high share of solar and wind. I think there was something in between here. Yeah, this shows you the development of prices of electricity for households in different countries. How they declined in Germany and the UK in real terms up until early this century, and how they then started to increase when these countries increased their share of solar and wind in their generation portfolio. You see the same thing in Australia, except that there are a few numbers missing. I contacted the source in Australia, but they told me, oh, I'm sorry, we don't have those numbers, so forget about that. And well, Denmark hasn't seen such a great increase in the price of electricity, but then again, they have been able to import from the neighbors. It's a small country, so they're a little bit unrepresentative, I would say. Then, how is it going to in Norway with the green transition? And this curve shows you the emissions of carbon dioxide in Norway. And we were supposed to reduce this by, a little bit more than, let's say, up until the level in 1990. That's the red arrow that you can see. We were supposed to remain pretty close to the emission level in 1990. And we were way above that. Unfortunately, we didn't meet that goal because what would that have meant? The increased emissions, they came mainly from the production of oil and gas. Without increasing that production, there wouldn't have been any petroleum fund, and all that goes with it. And then we are supposed now to get to something like reduce these emissions by 70 to 75% by 2035. That's the black arrow. And the other black arrow, the horizontal black arrow, shows you the time horizon. We have to do this. Does anybody think this is going to happen? I suppose these are promises that are made not to be kept, but maybe just for show, even though they're put into law. Doesn't sound likely to me. What are they going to do? Well, we have we have had an ambitious policy of going to battery-driven cars, which we, to a large extent, do have. And well, I shall admit this makes a certain sense in Norway when you can load these things up, you can charge them with hydroelectric power. So I suppose that battery-driven cars make more sense than in many other places if you want to reduce carbon dioxide emissions. Electrification of oil and gas platforms is another thing that they try to do to reduce emissions, which is a highly dubious way to go, because all you achieve is to transfer emissions from the Norwegian continental shelf to other countries. You electrify the platforms, you release gas that you can then export to Europe, and that's where it burned up. So the climate effect is plus minus zero. So this is absolutely the worst climate policy that I can think of in any case to achieve these goals. But I suppose that these ambitious climate goals up until 2030, 2035 is this, I think, will be achieved by buying quotas from some poor and medium-rich countries. And this is what we have been doing. We have been paying these countries for planting trees and not chopping down the forests. Now, there are two things by way of criticism to be said about that. Some of these countries, anyway, are among the most corrupt countries in the world. Take the two republics of Congo, for example. They are on the list of countries that we pay for not chopping down the trees. And furthermore, one president or prime minister or whoever it is, he can reverse this policy just like this. This is what Bolsonaro did when he got elected in Brazil. He allowed more chopping down of trees, more deforestation, and the attempts that Norway and some other countries have been making to increase the uptake of carbon dioxide in this forest, they were largely wasted. So the important question to me is what are the gains from these policies? They are costly. There's no question about that. It's a summary of these of those who have tried to construct economic models to assess these costs, and I'll just refer you to this publication. But very briefly, what the conclusion is that the costs are probably greater than the gains. The gains are highly uncertain, and the costs less so. We know pretty much what the costs are, and they are quite substantial. So, and there's a very large variation between different studies when it comes to these benefits. So here is my conclusion. There are many uncertainties surrounding the question of climate change. What is the climate sensitivity to increased carbon dioxide concentration? We have numbers going from, I think it is 2 degrees to 4. That's quite a big uncertainty, for one thing. Now, is higher temperature caused by the increase in carbon dioxide concentration? That's a contested theory, I would say, in any case. And certainly the amount of it is highly contested. Is this higher concentration of carbon dioxide due to human activities? Maybe some, maybe all. But there are those who argue with some good arguments that it's coming from the ocean, coming from the water. And are the effects of climate change positive or negative? Well, in this part of the world, the very mild increase in temperature that we've had since the Little Ice Age has, in my view, undoubtedly been for the better. And a little bit more of the same? Well, why not? The point is, the effects are certainly going to be different from different parts of the world. In some parts of the world, they are probably going, maybe negative, probably negative. In other parts of the world, positive. What's the net outcome? And for us, in all probability, positive. And then we have this question of high carbon dioxide concentration affecting plant growth in a positive way, which has been mentioned here already. So my basic question is this: are we going to destroy our reliable and cheap energy system for the sake of uncertain effects on the climate, which might be beneficial rather than bad. And I'll leave it at that.